Hello everyone, welcome to Science Solutions with Karishma. This is the part 3 of the chapter 1, Rational and Irrational Numbers from the ICSE Concise Mathematics of class 9. And in this video, we are going to solve the remaining questions from exercise 1b. The question number 1 of exercise 1b has been already done in my previous video. Today we are going to do the question number 2 where we have to find the square of the following numbers. So question number 2 is find the square of. Question number 1 is 3 root 5 upon 5. Now we have to find the square of this number. So let's do the square. 3 root 5 upon 5 whole square. Now this square means it is for numerator and denominator too. For example, if we have number a by b whole square, then this 2 or square is for both a square upon b square. So by the same method, we'll solve the question number 1. So here we'll get 3 square means 9 into root 5 square upon 5 square is equals to 9 into 2 will cancel the root, we'll get 5 only, and 5 5s are 25. So we'll cancel by 5 here. 5 1s are 5, 5 5s are 25. So we'll get 9 by 5. Dividing by 5, we'll get 5 1s are 5, remainder 4. Your answer will be 1 4 by 5. Next question, question number 2. It is root 3 plus root 2. By doing square of this, now see we are getting some kind of formula. It is a plus b whole square. So it is a square plus b square plus 2ab. So by applying this formula, we'll solve this second question. So here a is root 3, b is root 2. So a square means root 3 whole square plus b root 2 whole square plus 2 into a is root 3 into b is root 2. So here we get 3 plus 2 will cancel the root 2 plus. Now here we'll multiply only the numbers which are outside the root. That is, outside root 3 there is 2 and outside root 2 there is 1. So 2 1s are 2 and inside the root 2 3s are 6. So it is 3 plus 2 5 plus 2 root 6. The next question is question number 3. It is root 5 minus 2. By squaring, we'll get a formula a minus b whole square is equals to a square plus b square minus 2a into b. So here a is root 5 and b is 2. So a square means root 5 square plus b square means 2 square minus 2 into a means root 5 and b is 2. We'll get 5 plus 2 2's are 4 minus, again we'll multiply the number outside the root. So 2 2's are 4 and root 5. We cannot add or subtract 4 and 4 root 5 because it is connected with root. So we'll add 5 plus 4 9 minus 4 root 5. Next, question number 4. 3 plus 2 root 5. Squaring this, we'll get again a plus b whole square. A square plus b square plus 2ab. 2ab. So by applying this formula, we'll solve this question. Here a is 3, b is 2 root 5. A square means 3 square plus b is 2 root 5 whole square plus 2 into a is 3, b is 2 root 5. Let me mark it with brackets. So we'll get 9 plus 2 2's are 4 into root 5 whole square means square will cancel the root, we'll get 5 plus 2 3's are 6, 6 2's are 12, root 5. So 9 plus 20 plus 12 root 5. So 20 plus 9 is 29 plus 12 root 5. Now the next question in exercise 1b is question number 3. State in each case whether true or false. So we have to find whether the following are true or false. So here the question number 1 is root 2 plus root 3 equals to root 5. We have to prove that when we add root 2 and root 3, we'll have root 5. So see here, we cannot multiply, add or subtract the different roots. So we cannot subtract different roots, we cannot multiply different roots. We can only do these things in the same roots. For example, the same root like root 2 plus root 2, we can add the same roots. It will be 2 root 2. And we can also multiply the same roots like 2 into 2 equals to root will cancel root, you will have to like in squaring the same root like root 2 whole square. Square will cancel the root and we'll have 2. So we cannot add the same roots here. Therefore it is false. Question number 1 is false. Next we have question number 2. 2 root 4 plus 2 equals to 6. So we have to find 6 by adding 2 root 4 plus 2. So 2 and root 4 we can write as 2 into 2 because it is a square root. Square root means we have to find in pairs of 2. So there are 2 2's, so we'll have 2 outside the root. If it was cube root, we have to find the 3 pairs of the 2, then the 2 will outside the root. So here it is the square root, so we'll have 2 into 2 plus 2 or 2 into 2 will come outside plus 2. So we'll get 2 2's are 4 plus 2 equals to 6. So yes, it is true. Next is question number 3. It is 3 root 7 minus 2 root 7 equals to root 7. So we have to subtract the two same roots, that is root 7. So we have 3 root 7 minus 2 root 7. So we can add, subtract or multiply the same roots. The same root here is root 7. So we have 3 minus 2 is 1 root 7. So we'll get root 7. So yes, it is true. Next question is question number 4. 2 by 7 is an irrational number. For that we have to divide 2 by 7. So 0.1 decimal, then we'll get 1 0. 7 2's are 14, we'll have remainder 6. 1 0 60, 7 8's are 56, we'll have remainder 4. Add 1 0 and 7 5's are 35, we'll have remainder 5. 5 0 50, and 7 7's are 49, we'll have remainder 1, and 7 1's are 7, will have remainder 3, 0, 30. Then 7 4s are 28, will have remainder 2. If we'll add 1 0, then we'll again have the same number 20. That means all the thing will repeat again, and all the series, this series will be again and again. So these all number will reoccur. That means they all are recurring. Since the irrational numbers are not recurring, so that means they are rational, not irrational. So it is false. It's false. Next question is also the same thing. We have to divide 5 by 11. We have to show that it is rational. So let's divide 5 by 11. Put one decimal, we'll have 50, and 11 fours are 44. We'll have remainder 6, 60. 11 fives are 55. Again we'll have the remainder 50. Again the same thing will repeat. So 45 will be recurring. Since it has a recurring decimal, so that means it is a rational number. So it's true. The next question we have, question number 6. All rational numbers are real numbers. Question number 6 says that all rational numbers are real numbers. Real numbers are of two types, rational and irrational. So yes, rational number comes under real numbers. So all rational numbers are real numbers. Yes, it's true. The next question is question number 7. Question number 7 says that all real numbers are rational numbers. So here real numbers are, some are rational, some are irrational. So we cannot say that all real numbers are rational. So no, it is false. In the same way, question number 8 says that some real numbers are rational. So yes, some of the real numbers are rational. So yes, it is true. So if you have a clear concept about the different categories of numbers, you can answer all of these questions easily. So the next question is question number 4. So in this question, there is a given a universal set. From this universal set of numbers, we have to find rational numbers, irrational numbers, negative and positive integers. The universal set of numbers are -6, -5 3 by 4, minus root over 4, -3 by 5, -3 by 8, 0, 4 by 5, 1, 1 by 2, root over 8, 3.01, pi, and 8.47. So from this set of numbers, we have to find the rational numbers. So in question number 1, we have to find rational numbers. So rational numbers are those numbers which can be represented in the form of p by q, and the numbers which have terminating decimals, and also the integers, and the integers are maybe a positive, negative, including 0. So among these numbers, we have to find the numbers, the rational numbers. So first, let's see, in the form of p by q, the rational numbers are -5 3 by 4, -3 by 5, -3 by 8, 4 by 5, and 1.5. So all these numbers are the rational numbers which are in the form of p by q. Now we have to find the numbers which are integers, which may be positive or negative, and also the decimals. Integers are -6, 0, and 1. And the decimals are 3.01 and 8.47. So now we have found the rational numbers which are in the form of p by q, and these are the positive and negative integers along with 0, and these are the decimals. Now there is one thing remaining which is inside the root, that is root 4 and root 8. So root 4 can be written as 2 into 2, and 2 will come outside the root because it's the square root, so it's rational. But root 8 is not rational because inside the root there are 3 2's. So 2 will come outside and 1 2 will remain inside the root. So the number which is inside the root and cannot come outside, they are irrational. So only root 4 is rational. So finally we got all the rational numbers. So the rational numbers, set of rational numbers is denoted by q. So they are -6, -5, 3 by 4, minus root 4, -3 by 5, -3 by 8, 0, 4 by 5, 1, 1.5, 3.01, and 8.47. In the next question, question number 2, we have to find the set of irrational numbers. So irrational numbers are those which are neither terminating nor recurring decimals. So they are root 8 and pi. Root 8 is not recurring and not terminating, and pi 22 by 7 is also not terminating and not recurring. Root 8 is 2 into 2 into 2. Since it is the square root, 2 will come outside and another 2 will remain inside the root, and it is irrational because it has non-terminating decimals and they are not recurring. Next, question number 3, we have to find the set of integers. As you have already seen that the integers are a positive, negative, and 0. So they are -6. This is not the integer because they cannot be represented in the form of p by q. Minus root 4 is also an integer because it has the value -2, and 0, 1. The integers may be decimals, but they should be non-terminating. But here 3.01 and 8.47 are terminating, so they are not integers. So we found the integers -6, minus root 4, because it has the value 2, and 0 and 1. So they are the integers. Next question, we have to find the set of non-negative integers. Non-negative means we have to find positive integers. So among these, the positive integers are 0 and 1. So that was all in this video. In the next video, we are going to solve the remaining questions from the exercise 1B. Till then, keep watching and please subscribe to my channel.